Every year, 3 million people drive into one of the most beautiful places in America. They set up their cameras. They watch geysers shoot boiling water 180 feet into the air. They walk boardwalks over pools that glow electric blue and orange. They photograph bison grazing 50 feet from their cars. And almost none of them know what they're standing on. Beneath Yellowstone National Park lies a magma chamber so large it would take 2 hours to drive across it. The heat powering every geyser, every hot spring, every bubbling mud pool in this park comes from a column of superheated rock rising from deep inside the earth. A plume that has been burning through the North American continent for 17 million years. Yellowstone isn't just a national park. It's one of the largest active supervolcanoes on the planet. The last time it erupted, 640,000 years ago, it released 2,500 times more material than the 1980 eruption of Mount St. Helens. Ash covered half the continent. The sky darkened. Temperatures dropped globally. If it erupted today, the immediate blast zone would cover hundreds of miles. Ash would fall on cities thousands of miles away. The agricultural heartland of America, the breadbasket that feeds much of the world, would be buried. And yet, right now, today, families are eating sandwiches on picnic tables above it. Children are throwing coins into its hot springs. Tour buses are parked at its overlooks. 3 million people a year visit Yellowstone. They just don't know what's underneath. This is the story of what's actually down there. What it's done before. What it could do again. And why the scientists who spend their lives watching it aren't panicking, but they are paying very close attention. Most people think of a volcano as a mountain, a cone, a peak, something that rises above the landscape and announces itself. Vesuvius, Fuji, St. Helens. We have a very specific image in our heads of what a volcano looks like. Yellowstone doesn't look like any of them. That's because Yellowstone isn't that kind of volcano. It's a supervolcano, a category so different from a conventional volcano that the two barely deserve the same name. A conventional volcano builds upward. Pressure forces magma through a narrow vent, and over time, a mountain forms around it. The eruption, when it comes, is violent and destructive, but it's contained, localized. The damage is measured in miles. A supervolcano works in reverse. Instead of pushing magma up through a single vent, a supervolcano accumulates it in a massive underground chamber, a reservoir of molten rock so large that when it finally releases, the ground above it doesn't just erupt, it collapses. The entire roof of the chamber falls inward, leaving behind a depression in the earth called a caldera. Yellowstone's caldera is approximately 30 miles wide and 45 miles long. It is so large that early geologists couldn't see it. They were standing inside it and didn't know. It wasn't until aerial photography and satellite imaging became available that scientists finally understood the true shape of what they were looking at. The mountains surrounding Yellowstone? Those aren't the volcano. Those are the rim of the crater left behind by the last eruption. The entire park, every geyser, every hot spring, every meadow and river and scenic overlook sits inside a supervolcanic caldera. Yellowstone has erupted 3 times in the last roughly 2 million years. The first eruption, approximately 2.1 million years ago, was one of the largest volcanic events in the history of this planet. It released an estimated 600 cubic miles of material, enough to bury the entire state of Texas under 10 feet of ash and rock. The second eruption, roughly 1.3 million years ago, was smaller, but still hundreds of times larger than any volcanic event in recorded human history. The third, approximately 640,000 years ago, created the caldera we see today. Those 3 dates tell a story that geologists have been analyzing carefully for decades. 2.1 million years, 1.3 million years, 640,000 years. The intervals between eruptions are roughly 600,000 years apart. It has now been approximately 640,000 years since the last one. That number gets repeated a lot in conversations about Yellowstone, sometimes with alarm, sometimes with reassurance, almost always without full context. Because the truth about what it means is more complicated and more interesting than either the panic or the dismissal suggests. But to understand it properly, you first need to understand what's actually happening underneath this park right now. Every national park is beautiful because of what's on the surface: the mountains, the rivers, the wildlife. Yellowstone is beautiful because of what's underneath. 6 miles below where you're standing, rock that would normally be solid is partially molten, heated by the same mantle plume that has been pushing upward for 17 million years. That heat doesn't stay underground. It finds every crack, every fissure, every weakness in the rock above it, and pushes through. The result is the most geothermally active place on Earth. Yellowstone contains more geysers than anywhere else on the planet, over 500 of them. Roughly half of all the geysers that exist in the world are here, in a single national park in Wyoming. A geyser isn't just a hole in the ground that shoots water. It's a precision instrument built by geology over thousands of years. Below the surface, water seeps down through cracks in the rock until it reaches a chamber close enough to the heat source to begin boiling. But it can't escape. The weight of the water above it keeps it under pressure, preventing it from turning to steam. The temperature climbs higher than the normal boiling point. The pressure builds. Then something triggers a release. The water nearest the surface flashes to steam. That expansion forces the water above it upward, which reduces the pressure on the water below, which flashes to steam, which forces more water up. The entire column erupts. Old Faithful has been doing this every 60 to 90 minutes for as long as anyone has been watching. Not because of magic or mystery, because the geometry of the underground chamber it sits above is almost perfectly calibrated to refill and reheat on that exact schedule. It is, in the most literal sense, a natural machine, running on heat from the Earth's interior. Reliable enough that Yellowstone rangers post predicted eruption times and are accurate within 10 minutes. But geysers are only the most dramatic expression of what's happening here. The hot springs are stranger. The grand prismatic spring, the one visible from space, the one that looks like it was painted by someone who had never seen Earth before, gets its colors not from the minerals in the water, but from life, bacteria. Specifically, heat-loving bacteria called thermophiles that exist nowhere else on Earth in the same concentrations. The blue center is too hot for anything to survive. Water there reaches nearly 90 degrees Celsius. But as the water spreads outward and cools, different species of thermophiles colonize different temperature zones, each one producing its own pigment: yellow, orange, red, brown. The rings of color you see from above are a map of which organisms can survive at which temperature. These bacteria aren't just interesting, they changed science. In 1969, a microbiologist named Thomas Brock discovered a heat-resistant enzyme in a Yellowstone hot spring, a protein that could survive temperatures that would destroy almost any other biological molecule. That enzyme, called Taq polymerase, became the foundation of PCR, polymerase chain reaction, the technique used to amplify and analyze DNA that underlies almost every genetic test, forensic investigation, and medical diagnosis performed today. The COVID tests that were administered billions of times around the world between 2020 and 2023 relied on technology derived from bacteria living in a Yellowstone hot spring. Below the hot springs and the geysers, the ground itself is moving. Yellowstone breathes. The entire landscape rises and falls by inches every year, sometimes more, as magma shifts in the chamber below. Scientists call it ground deformation, and they measure it continuously with GPS sensors placed throughout the park. Between 2004 and 2008, the floor of Yellowstone Lake rose by nearly 3 inches as magma pushed upward from below. Then it subsided. Then it rose again. The ground you walk on here isn't stable. It never has been. It's the surface of something alive. Visitors come to Yellowstone expecting the geysers. They leave talking about the animals. Yellowstone is the largest intact ecosystem in the temperate world. Every predator, every prey animal, every scavenger that existed here before Europeans arrived still exists here today, in numbers that would have been unimaginable 50 years ago. That didn't happen by accident. In 1995, wildlife managers made a decision that was deeply controversial at the time and has since become one of the most studied conservation stories in history. They brought wolves back to Yellowstone. Grey wolves had been systematically hunted to extinction in the region by the 1920s. For 70 years, the park existed without its apex predator. And in those 70 years, something happened that no one fully anticipated. The elk population exploded. With nothing hunting them, they grazed wherever they wanted, including riverbanks and valley floors where their constant feeding stripped vegetation down to bare ground. Rivers began to erode. Songbird populations dropped because the trees they nested in were being overgrazed. Beaver colonies disappeared because the willows they depended on were gone. The removal of one species had quietly unraveled an entire ecosystem. When the wolves returned, The change was faster than anyone predicted. Not just because wolves killed elk, but because elk changed their behavior. They stopped grazing in open valleys where wolves could see them. They moved. They stayed in the trees. The riverbanks recovered. Willows and aspens grew back. Beavers returned and built dams, which created wetlands, which brought back songbirds, otters, muskrats, and fish. The rivers themselves changed course, stabilized by the returning vegetation, no longer cutting sideways through bare banks. Ecologists have a name for this: a trophic cascade. A chain reaction triggered by a single species at the top of the food chain that reshapes everything below it, including, in this case, the physical landscape itself. The wolves didn't just change what lived in Yellowstone, they changed the shape of its rivers. Today, Yellowstone has one of the densest concentrations of large mammals in North America. Over 5,000 bison, the largest wild bison population on the continent, move through the park in herds that stop traffic for miles. They are the direct descendants of the approximately 23 animals that survived the near-total extinction of their species in the 19th century. From 23 animals to over 5,000 in a single national park. Grizzly bears hunt here. Mountain lions move through at night. Pronghorn antelope, the fastest land animal in the Western Hemisphere, cross the park in ancient migration corridors that predate the United States by thousands of years. But the most remarkable life in Yellowstone isn't the largest, it's the smallest. The thermophiles, the heat-loving microorganisms that paint the grand prismatic spring in rings of yellow and orange and red, are members of a domain of life called archaea. They are among the oldest forms of life on Earth. Their ancestors were alive before there was oxygen in the atmosphere, before multicellular life existed, before the oceans had taken their current shape. They have survived every mass extinction, every ice age, every asteroid impact in the last 3 billion years by doing exactly what they do in Yellowstone, finding the extreme edges of survivability and making themselves at home there. Scientists who study these organisms believe they hold clues to the origin of life on Earth, and possibly to what life might look like on other planets. Because if life can exist in boiling, acidic water inside a supervolcano in Wyoming, the question of where else it might exist becomes much harder to answer with certainty. Yellowstone isn't just a window into the Earth's interior. It might be a window into what life looks like at its most fundamental level. And that makes what's happening to this place, above and below the surface, worth paying very close attention to. There is a moment that happens to almost everyone who visits Yellowstone for the first time. It usually occurs somewhere unexpected. Not at Old Faithful, with its crowds and its viewing benches and its predicted eruption times posted on a board. Somewhere quieter, a trail through a pine forest that opens suddenly onto a basin of steaming pools. A road that crests a hill and drops into a valley filled with bison as far as you can see. A canyon so unexpected, so out of place in a park you thought you understood, that you stop walking and just stand. The moment when Yellowstone stops being a national park and starts being something harder to explain. The Grand Canyon of Yellowstone is one of the least expected things on Earth. A canyon 380 feet deep, carved by a river through volcanic rock into colors, yellow, orange, cream, pink, that look digitally enhanced even when you're standing at the rim looking down at them. Two waterfalls drop into it. The larger one, the Lower Falls, drops 308 feet, nearly twice the height of Niagara Falls. No one talks about it as much as the geysers. It might be more extraordinary than any of them. Drive north through the park and you reach Mammoth Hot Springs, where boiling water rises through limestone and deposits minerals as it cools, building terraced structures of white and orange travertine that grow visibly over years. The formations shift. New ones emerge, old ones dry out and turn pale as bone. It looks like something from another planet. It is technically in Wyoming. Head east into the Lamar Valley and the park transforms entirely. Wildlife biologists call it the American Serengeti, a broad, open valley floor where bison herds move in slow, unhurried columns at dawn. Wolves patrol the ridgelines at dusk, and grizzly bears fish the rivers in spring when the cutthroat trout are running. There are people who drive to Lamar Valley before sunrise every single morning of a week-long trip and consider it the best thing they have ever done. In winter, Yellowstone becomes something else again. The crowds are gone. The roads into most of the park are closed to regular vehicles. Snow covers everything. And the geysers, releasing the same heat they release in July, produce clouds of steam that rise hundreds of feet into the frozen air, visible from miles, catching the low winter sun in ways that don't seem real. Bison stand in thermal areas where the ground stays warm, steam rising around them, breath visible, completely unbothered by the cold that would kill an unprotected human in hours. It is, by most accounts of people who have seen it, one of the most beautiful things this country has to offer. And then there is the night. Away from the nearest city by hours in every direction, Yellowstone sits inside one of the largest dark sky areas in the continental United States. On a clear night, the Milky Way is not a faint smear on the horizon. It is overhead, dense, structural, the kind of sky that makes it difficult to understand how anyone who has seen it can live contentedly under city lights. Above a supervolcano, under a sky full of stars. There is nowhere else on Earth quite like this.
Here is the thing about Yellowstone that takes a while to fully settle in. This place has been here for 2 million years. The supervolcano was erupting before our species existed. The hot springs were running before the first humans crossed into North America. The bison, or their ancestors, were grazing this valley before any civilization on Earth had learned to write.
and it will all still be here long after us. We almost lost it. In the 19th century, before Yellowstone became the world's first national park in 1872, hunters were decimating the bison herds, poachers were destroying the wildlife, and developers had plans for the geysers and hot springs that would have turned them into tourist attractions of a very different kind. The decision to protect this place, made by people who had the imagination to understand that some things are worth more untouched than developed, is one of the best decisions this country has ever made. Not just for Americans, for everyone. What Yellowstone shows us, more than anything else, is what the Earth looks like when it's left alone to do what it has always done. Not managed, not controlled, not optimized, just running. On its own time, on its own terms. The wolves deciding where to hunt, the rivers deciding where to flow. The supervolcano deciding, on a schedule no one can predict, when it will next remind us what this planet is actually made of, underneath all the roads and buildings and cities we've laid across it. 3 million people visit Yellowstone every year. Most of them leave changed in some way they struggle to articulate. Something about standing next to a geyser that has been erupting since before your great-great-grandparents were born, or watching a wolf cross a valley at dawn, or looking down into a canyon that has no business existing in the middle of Wyoming. Something about all of that makes the rest of ordinary life feel briefly, usefully, small. That's what extreme places do. They recalibrate you. There are places on this planet that don't ask for your attention. They just take it. Yellowstone is one of those places, and it's far from the only one. Every week we find another one, another corner of this world that operates on its own terms, indifferent to everything we've built around it. If that sounds like something worth showing up for, hit subscribe. We'll see you next week. One last thing before you go. You've now seen what Yellowstone looks like from the outside, but we're curious. If you actually got there, where would you spend your time? The geyser basins? Lamar Valley at first light? The canyon? The backcountry in February when the crowds are gone and the bison are standing in the steam? Tell us in the comments. Every single response gets read. Thanks for watching.